Hi everybody. This is a bonding unit. It's it will be covering chapter 8 and 9 of your textbook. We will be talking about covalent bonds and ionic bonds. So as I said, it's a bonding unit. We will learn what actually the definition of a bond is, what is the difference between bond and intermolecular forces that holds the molecules together, and covalent bonds, ionic bonds, and the molecular structure mm, that that is formed because of those bonds. So first of all, let's define what bonding is. So let me grab the pen. Chemical bond. So it's a chemical bond that is formed by a chemical reaction. So it's not a mixture. It is that you're going to take hydrogen, which is a diatomic element, and oxygen, which is another diatomic element, and you're going to make a bond of oxygen and hydrogen. So this thing which is holding these two atoms together is called bond. Whether it is between hydrogen, hydrogen, oxygen, oxygen, or oxygen and hydrogen. So chemical bond is a force that holds two atoms together. So keep that in mind. When we learned about 7 diatomic elements, if you remember, 7 diatomic elements in the periodic table, we said that hydrogen is always 2 or chlorine is always 2. So how is hydrogen always 2? Because hydrogen bond atoms are attached by a bond. There is a force that is holding the two atoms of hydrogen together. There is a force that is holding two atoms of chlorine together, and that force is called bond. So there are two types of bonds basically that we learn at this level. One is covalent bond and one is ionic bond. Both of these bonds involve electrons. Okay, so it's the electrons that are holding them together. It's not protons or neutrons. And which electrons? We will be talking about valence electrons. So when we learned last unit where we did the electronic configuration, we were doing electronic configuration such as 1s2, 2s2, 2p6, 3s, let's say 1. So which element is it? 11, sodium. So we talked about valence electron, the electrons in the outermost energy level. That's only 1. So that means sodium has 1 valence electron. Chlorine has 7 valence electrons. So whenever there is a bond formed, it is always formed by those valence electrons. Like sodium has 11 electrons, chlorine has 17 electrons. But the electrons that are involved in any kind of bond are the electrons that are sitting outside. So sodium has only 1 out of 10 that is sitting outside in the outermost energy level, and chlorine has 7. So 1s2, 2s2, 2p6, 3s2, 3p5. This is the electronic configuration for chlorine. So chlorine has 17 electrons, and out of 17, the outermost energy level is 3, and it has 7 valence electrons. So these are the electrons that are involved in bonding. So what is going to happen is sodium is going to say, okay, I'm going to let you take mine. So sodium will transfer its electron to chlorine. Okay, and so chlorine will take 1, sodium will lose 1, and that's called an ionic bond. But I'll get into that detail later. At this point, I just want to talk about that electron dot diagram or Lewis structure is very important to understand the bonding. And so the concept of valence electrons is very important to understand the bonding. So these are the dot diagrams. Lithium has only 1 valence electron, beryllium has 2 valence electrons, boron has 3 valence electrons, carbon has 4, nitrogen is 1, 2, 3, 4, 5, oxygen is 1, 2, 3, 4, 5, 6, fluorine is 1, 2, 3, 4, 5, 6, and 7, and neon is in group 18, so that means its octet is complete. So it has 8 valence electrons. So the maximum valence electrons you can have, maximum number of valence electrons ever, will be 8. There are sometimes in the test you are given a lot of electrons, like you will see silicon has 14 right here, these kind of questions come on the test. So it is definitely a wrong option, because there can never be any more than 8 electrons. So maximum number of valence electrons will always be 8. So there is a rule that's called octet rule, or rule of 8, because octa means 8, that elements will try to gain or lose electrons to achieve the noble gas configuration. So either they will gain or lose to get 8. Okay, this is noble gas. Neon is in group 18. So it's a noble gas. So everybody here who has either 1, 2, you see 3, 4, 5, 6, 7. So all of these are willing to lose, gain, share, whatever, to get 8. Okay, so that's called rule of 8. And if you pay attention, it is going by the group number in the periodic table. So group number 1, all elements in group number 1. So it will be lithium, sodium, potassium, rubidium, cesium, francium. Everybody in that group has 1 valence electron. So they all have this dot diagram. Everybody in group 2 has 2 valence electrons. So everybody down the group has 2 dots around them. So whatever the dot diagram that I did is good for anyone in that group. Like oxygen also has sulfur. Sulfur is also in group 16. So that means sulfur also has 6 valence electrons. So same dot diagram. So keep it in mind that the number of dots or number of valence electrons go by the group number, and you just show them around it. You can go, it doesn't matter which direction you go. You can go right or left, or, it doesn't matter where you start from, but it has to be in 4 corners. Okay, you're not supposed to sprinkle them around the symbol. All right, so it's valence electrons. So as I am saying, according to the octet rule, elements are going to gain or lose electrons to get the 8. So what happens is that, let's talk about sodium. We were doing the electronic configuration of sodium. So sodium is, it has 2 in the first energy level, and how many? 2, 4, 6. You see 8 here, 8 in the second energy level, and then 1 in the third energy level. This is the third energy level. So sodium has 1 valence electron, and chlorine has 7. So when sodium, it is hard for sodium to gain 7, because nobody will give 7 to sodium to make sodium happy. So what's going to happen is that sodium is going to lose that electron. When sodium loses that electron, what is left? Because that energy level was there, because electron was revolving in that energy level. So when that electron is gone, what is left for sodium is this becomes the outermost energy level. Okay, and 2, 4, 6, and 8, it already has 8. So when this is gone, this is the sodium positive 1, because sodium lost an electron. So, and it has 8. So the sodium is going to lose the electron to get 8. So anyone who has 1, 2, or 3 valence electrons, they are going to lose those electrons to get positive 1, positive 2, positive 3 charge. So whenever any element loses the electron, it is called cation. So all of these are cations. Okay, cations are formed by the loss of electrons, and that process is called oxidation. So you need to understand the term. So we are oxidizing sodium. Sodium is oxidized, calcium is oxidized, aluminum is oxidized. Now if I look at the periodic table, this is the periodic table, and if I do the dot diagram, you have group 1, group 2, 3 to 12, then 13, 14, 15, 16, 17, and 18. So this is how many valence electrons they have. Let's do the valence electrons for them. So it's 1, 2, what did I do? 1, 2, 3, 4, 5, 6, 7, and 8. This is how many valence electrons they have. So who is the one who doesn't need to do anything? According to the octet rule, they want to have 8 in the as valence electrons, 8 in the outermost energy level. This whole group doesn't have to do anything. But those who have 1, 2, or 3 valence electrons, these are all metals. This part of the periodic table is metals. They are going to lose the electrons, okay, and become cations, positive ions. This process is called oxidation. So anyone who is sitting in this part of the periodic table is going to be oxidized and they will make ions that are called cations. Whereas everybody who has 5, 6, or 7, they will gain 1, gain 2, or gain 3, and they will make anions, negative ions. Anions means negative ions. This process is called reduction. So they're going to gain to get 8, they're going to lose to get 8. So once again, let's do the definition of cation and the definition of anion. Anion is formed by the gain of electrons. Cation is formed by the loss of electrons. Loss of electrons, and that process is called oxidation. Gain of electrons, that process is called reduction. So cations means loss of electrons and you make positive ion. Anions mean you gain electrons, that makes negative ion. But why is it a positive ion? It's loss of electrons. Let's look at it. Sodium has 11 protons and 11 electrons. When sodium loses an electron, the number of protons doesn't change, but what happens to the number of electrons? It is 10, okay, because it has lost an electron. So what charge is it going to get? It has one extra positive on it. So because of that extra positive on it, it is called positive 1 because it has lost 1 electron. So there is a 1 extra proton on it. For example, you have calcium. Calcium has 20 atomic number, okay, and calcium has 2 valence electrons. So 20 atomic number means 20 protons, 20 electrons. But when it loses these two, okay, number of protons never changes, but what happens to the electrons? It's 18 electrons. So now, after the loss of these 2 electrons, calcium has 2 extra protons on it. So it will shape positive 2. So this is why you have a positive charge. So we call it a cation, a positive ion, and it shows the oxidation number. So when you write, when you write sodium positive 1 or you write calcium positive 2, this is called oxidation number. Oxidation number or charge. Okay, so positive 1. If aluminum is going to lose 3 because aluminum has 3 valence electrons, so it's going to lose all 3. So it becomes positive 3. So that is the oxidation number of aluminum or the charge of aluminum, and it is a cation. So one more time, cations, positive ions. That process is called oxidation. So oxidation means loss of electrons. Okay, on the other hand, the reduction is the opposite of oxidation. What happened to my pen here? It is taking some time. Okay, I think something is wrong with me. Okay, so reduction is the anions. So let's say you have chlorine. Chlorine has 17 valence electrons. So when chlorine gain 1 valence electron, it makes it 8. So earlier chlorine has 17 protons and 17 electrons. That was the dot diagram, chlorine with 7 valence electrons. Now when chlorine gained an electron, the number of protons never change. So you have an extra negative on it. So that makes it negative 1. Okay, so now you have a negative 1 ion. So negative ion is called anion, and the process is called reduction. That means gain of electrons. Gain of electrons. And this is the oxidation number of chlorine. So hopefully you understand what is cation, anion, how are they formed. So these are the 2 types of ions. It is based on valence electrons. Anybody who has less valence electron is going to lose and more is going to gain. So here are all the definitions. Charge of the monatomic ions. So again, ions, lithium is going to be always positive 1. Everybody in group 1 will be positive 1. Okay, so these are the oxidation states. So anybody who in group 1 is positive 1. Anyone in group 2 is positive 2. Anyone in group 3 is positive 3. This one varies. This could be positive 2 or positive 4. Usually they're 4, but it can even lose again some. So it can go anywhere. Usually it's positive. Neons don't need to do anything. So all of the neon means the noble gases. The noble gases don't gain or lose. So their oxidation state is 0. Fluorine, they have 7 valence electrons, so they're going to gain 1, gain 2, gain 3. So these are the oxidation states or oxidation numbers. For nonmetals, it's negative. For metals, it's positive. Now, what is ionic bond? Ionic bond is an electrostatic force that holds oppositely charged ions or oppositely charged particles together. So we have oppositely charged particles, sodium positive 1 and chlorine negative 1. Okay, and the oppositely charged particles will attract each other and they will make a bond, or these will be held together by a force called ionic bond. Okay, so for ionic bond, then you have to understand ionic bond is formed by transfer of electrons. Okay, so ionic bond is formed by transfer of electrons. Okay, where is this transfer happening? It is going from metals to non-metals. So metals are going to lose ions, non-metals are going to gain ions. So ionic bond is formed by the transfer of electrons from metals to non-metals. You have cations and you have anions. Okay, and they're held together. Next thing you want to talk about, I have a lot of slides in between here. So we want to talk about binary compounds. Binary compounds means compounds of 2 elements. So binary ionic compounds, compounds of only 2 elements. Bi means 2. So contains only 2 different elements. So crisscross method is used to get the formula for ionic compounds. So crisscross method, overall charge for the ionic compound is going to be 0. So cations are positive, okay, they are written first, and anions are negative, you will write them after. So let's say I want to make a bond between barium and chlorine. So barium has a positive 2 charge, so I'm going to write the metals or the positive ions first and non-metals or the negative ions afterwards. So I have a positive 2 for barium and Cl is negative 1. So if they're opposite charges, like as you see here, I'm going to crisscross it. The 2 goes to chlorine and 1 goes to barium. So you see it is Ba1Cl2. We don't usually write 1. So if I have aluminum positive 3 and Cl minus 1, so 1 goes to aluminum, 3 goes to Cl. So it will be AlCl3. You don't write positive or negative because the purpose of this whole thing is to cancel out the charges, to make it neutral. So the overall charge for the ionic compound is going to be 0. And we're going to have the least common multiples. So it would not be, we will have to simplify the formula. So if it is, as you see here, 2 to 4, so instead of having V2S4, I will simplify it to 1 to 2. So the formula will be VS2. So keep in mind that we crisscross the charges and we simplify it. If the charges are the same, they cancel each other and all you do is write the symbols together. But when you're writing the symbols together, make sure you have metal and then non-metal. Okay, they go separate, not together. I'm sorry, metals and non-metals. It has to be metal first, then non-metal, not the other way around. So let's practice this. I have sodium plus 1, okay, chlorine minus 1, nitrogen is negative 3, oxygen is minus 2, iodine is negative 1, sulfur is negative 2, calcium is plus 2, and aluminum is plus 3. So sodium and chlorine, they have positive 1, negative 1. Equal charges balance each other. Okay, equal charges balance each other. So all you are doing is writing the symbols together. But if they're not equal charges, like sodium is plus 1 and nitrogen is minus 3. So as I said, I'm going to crisscross it. 3 goes to sodium and 1 goes to nitrogen. So the formula is going to be Na, and then you get 3 from this nitrogen. and the 1 goes to nitrogen, but I don't write 1, so Na3N. So again you see here the 2 goes to sodium, so Na2, and 1 goes to oxygen, and you don't write 1. Alright, so Na plus 1 and iodine minus 1, so equal charges balance each other, and all you're doing is writing the symbols together. You make sure that it has to be metal or positive ion and then non-metal, not the other way around. So sodium is plus 1, sulfur is minus 2, and I'm going to crisscross when they're opposite. 2 goes to sodium, 1 goes to sulfur, so it will be Na2S. I don't have to write 1, but when they are equal charges, they cancel each other, and you just write the symbols together. So this is how you write the formula of ionic compounds, the binary ionic compounds, which have only 2 elements. So when it's only 2 elements, we crisscross their charges. And where are we getting the charges from? Where are we getting this positive 2 from? The periodic table. Okay, so let's see what is next. Naming binary compound. So when you're naming the binary compound, since we are writing the metals first, I'm going to write the name of the metal first, and metals don't change their name. Okay, so metals or positive ions don't change their name. So positive ions or metals don't change their name. The negative ions, okay, the negative ions change their name to end with IDE. So if Cl is chlorine, CHLORINE, Cl minus 1, which is a negative charge, will be chloride. Okay, if this is oxygen, but then oxygen gain 2 electrons, it has a negative charge, it becomes oxide. So this is what I'm saying, that they will change their name to end with IDE. So let's see what Na stands for. You go to the periodic table and see what Na stands for. Na is the symbol of sodium. So positive ions don't change their name. The negative ion is always, the second half is always negative. So the second half is going to end with IDE. So chloride. Okay, Mg is magnesium, and this is a metal, so it's not going to change its name. But fluorine is a non-metal, so fluorine is going to change its name to fluoride. Okay, so make sure that all of the anions, okay, all of the anions which are negative ions end with IDE, whereas the positive ions don't change their name. So you have lithium, and this is oxygen, so it becomes lithium oxide. So go ahead and complete this page, and then we will go from there. So lithium oxide, magnesium sulfide, so all of these will end with ide. Cesium, so how do you write the formula of cesium oxide? So you go to the periodic table, get the charge for cesium. Cesium is in group 1. Okay, so let me draw the periodic table. We talked about, maybe somewhere in there I had the periodic table. I have a periodic table somewhere, yes. So cesium is right here. Okay, so cesium has a positive 1, this is positive 2, this is positive 3, negative 1, negative 2, negative 3. So if cesium is here, that means cesium has a charge of positive 1. So if I am doing the formula for cesium oxide, oxygen is right here. Okay, so cesium is plus 1 because cesium is in group 1, and oxide means oxygen is minus 2 because the periodic table tells me oxygen is minus 2. So what I do is I crisscross it, so it will be CS2O1. Okay, so I go to the table. So cesium plus 1, oxygen minus 2, so it will be CS2O. So again, barium is in group 2, so the charge for barium is positive 2. Chlorine is in group 17, so minus 1. So you crisscross it, BaCl2. Make sure that the formula does not have any positive or negative on it. Okay, the formulas have to be neutral. That's all for ionic compounds. You know, ionic compounds are formed by transfer of electrons from metals to non-metals. Let's only do this much practice, and then I will talk about polyatomic ions later on. Thank you.